Hello, my name is Adam DeMello, and for this presentation, I am going to be discussing MPLS or multi-protocol label switching in Cisco networks. So a little bit of an introduction. MPLS is a way to move data efficiently in a network by using different labels instead of what we usually would use IP addresses. So MPLS is mostly used in service providers and enterprise networks where speed and routing control are the forefront of what needs to be done. Um, for this presentation, I'm going to explain how MPLS works, which kind of devices use it, and a little bit of a description of a certain lab that I tested in GNS3. So what exactly is MPLS? MPLS routes data based on labels instead of IP lookups or IP addresses at each router, and this differs from the traditional Cisco packet tracer models we've been doing with those certain network topologies. It also operates between layer 2 and layer 3, which is also known as layer 2.5, and it improves speed, traffic engineering, and VPN support. So where exactly is MPLS used? MPLS is seen in large-scale enterprise and ISP networks, VPNs, and secure customer connections, certain applications that are in need of low delay and traffic prioritization. The benefits of using MPLS are it is fast and efficient, it's flexible and scalable, and it allows for better traffic control throughout the networks. Devices that support MPLS. Cisco devices, of course, there are many that support MPLS, ranging from Catalyst 9500, which focuses on core switching, ASR 1000, which focuses on edge routing, Nexus 7000, which focuses on data centers, and iOS/iOS XE, which focuses on supports MPLS configurations. And some other vendors that support MPLS are Juniper MX series, Nokia 7750SR, and Arista 7280R. So to test MPLS in these networks, I used GNS3, and in this lab, it consisted of 5 routers, which were labeled CE1, PE1, P1, PE2, and CE2. And that's how the topology started off. CE1 and CE2 were labeled as the customer routers, with PE routers connecting the customers to the MPLS core, and P1 was the core provider router. The configuration in this network topology for MPLS was I set up the IP addresses between routers, also enabled OSPF in the provider core, enabled MPLS and LDP for label distribution, created VRFS, and configured MPBGP for VPN routing, and I verified label tables and tested end-to-end connectivity. So to notice that MPLS is working and in action, some things that were shown were with the command show MPLS forwarding table, that showed the correct label assignment, with show MPLS LDP neighbor, that confirmed the label exchange between the routers, pinging from CE1 to CE2 succeeded using the label switching method, and traffic didn't rely on traditional IP routing across the provider core. Some challenges when using MPLS are it's a little bit complex to figure out and kind of configure how it works. It requires a lot of understanding of different kinds of protocols. It's more difficult to troubleshoot due to the label switching method. Not all routers support MPLS, so you have to find specific ones, like the one I use for the network topology. There's no built-in encryption. You have to combine with other technologies for more security. The key learnings with working with MPLS is I found that MPLS is efficient and widely used in large networks. Cisco has strong support for MPLS across hardware and software. GNS3 is a powerful, accessible tool that allows stimulation of real-world MPLS labs, and learning MPLS builds important skills for networking careers. And to kind of conclude my discussion on MPLS, MPLS offers better speed and control than traditional routing methods. This presentation showed that MPLS can be tested effectively using GNS3, and although it is complex, MPLS is a key technology for service provider networks, and understanding label switching, VRFs, and BGP adds valuable networking knowledge. And these are just some references that help me gain an understanding on MPLS. Thank you for listening to my presentation.